All right, let me know when you guys are ready, and or number 3, and we'll get going.
I'm there, so.
I'm there.
What about, okay. Given the linear regression equation y equals 2 plus 1.5x, what is the y-intercept?
2.0.
2.0.
Yep. And the slope is going to be 1.5?
Yep.
Okay. Given the linear regression equation, what is the predicted value of y when x equals 16?
1.
Oh, you're already there.
Yeah, how the heck?
Well, minus 3 plus 4 is 1.
Yep. You're right.
All right.
So do you think it matters if we put 1, or do we need to put 1.0? It doesn't. We just put 1, right?
Yeah, we can just put 1.
Yeah.
Okay. For the next 7 questions, use the data file math self-efficacy. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. Okay, so let's pull that up. Plug it in. So confidence, be sure to use the confidence data for the explanatory variable.
Oh, interesting. I would have done it just the opposite, I think.
Yeah.
So wait, be sure.
It says be sure to use the confidence data for the explanatory variable and the score data as the response variable.
And what is it, the score data for the other one?
Yeah.
Yeah.
Okay.
They only have the 2 data, don't they?
Yeah.
Yeah.
Okay.
Okay.
Okay, I just barely got mine plugged in. Looks like that first question is asking us to make a scatter plot of the 3 data shapes introduced of the reading. Wait a minute. Make a scatter plot of 3 data shapes introduced in the reading. Which shape best describes the data?
So it looks like hot dog shape to me.
Me too.
That's what I would say. Pretty odd looking hamburger if it was hamburger. No banana, so.
Wait, let's see. Well, unless it's no, it can't. Do you think it's banana? No, it's not curved enough, right?
Not banana.
Yeah, hot dog.
Yeah.
Yeah.
Okay, based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? Looks like simple linear regression is appropriate. If simple linear regression is used for this data, the results will not be reliable. And simple linear regression is not appropriate for this data.
I would say A.
Yeah, that's
I think it's appropriate. Right? If it made some crazy shape or if it didn't seem linear, then we would go with one of the others, but
yeah.
Yeah.
I would say that one too. Okay. How many observations are in the data?
And this doesn't give us an N, does it?
No, but I think it's 138.
Did you find that somewhere?
No, I just went to the bottom and found that we were at line 142 and we started at line 4 and subtracted.
So I took 142 and then I subtracted the 3 that we're not using for data and I got 139. Is that right?
What 3 are we not using?
Well, on my,
Oh, I started on line 4, so yeah, I guess you're right. Yeah, 139. Yeah, Jennifer says it's 139.
that's
Okay.
right?
Well, mine also starts on 4. So if it starts on 4, then we're missing 3. So yeah, I would say go 142 minus 3, so 139.
Yeah.
Okay. Actually, would it be 139 or would it be 139 times 2?
No,
That's what
it's
I was just gonna
139.
say.
Jen already took the quiz, and I think maybe, is this the one that you missed, Jen? Oh, she just cut out. But she just texted and said it's 139.
Okay.
Oh. So I think it's just wanting to know the observations total, because we're observing 2 separate things, but I mean, I guess I don't know, but that would be my like.
I think you're right. I think it's 139. I don't think
Okay.
there's anything really hard about that.
Yeah, that's just probably me overthinking it there.
Yeah, she says it's 139. She got that one right.
Okay.
So
What is the y-intercept? Let's see.
So-
It looks like
I have 18.690.
yes, I have that as well.
Okay.
18.6. And the slope is the next one.
12.695.
695. Yep. Okay. What is the predicted value of y when x equals 4?
I have 69.469.
that's what I've got too.
Okay, hold on. So did you just plug in a 4 in that blue box, right?
Yep.
Yeah.
And then it gives you the predicted value is 69.469?
Mm-hmm.
Perfect. Okay, just making sure. $69.469. Okay. Okay. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for the values of x? Because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
I don't know what I don't understand that question. So
I'm confused. Okay, let's see.
If we do 139 times 6, 834 would be the highest. That if everybody said they were 6s, 834 would be the highest for y, right? Or for x. So if we plug in 834 for x, that should give us the highest prediction for y, right?
That makes sense to me. So you're putting 834 in for x?
Yeah, I took 139 because that's how many people we have, right?
Right.
Multiplied that by 6 because that would be the x variable. That gave me 34. Plug that in for x in that blue box. And then I would think it would be the answer, the number that's in the last square on that same line as the x value.
The prediction interval for y?
Yeah, wouldn't it be the highest of that?
So 12,282.520.
okay, so Jen just texted and said she got 12 wrong but did it by hand. Try the software. Use the largest X number. It's like 5.93.
Wouldn't we use the largest Y, though, if we're involved with the Y? Oh, wait. What is the maximum predicted value of Y for these values of... Oh, yeah. So I think we'd be wanting to look at Y.
Well, Y is the answer that we want, the maximum predicted value of Y. But we're told that the confidence data, which is X, is on a scale of 1 to 6. And if we use these values of X, what's the maximum predicted value of Y? Oh, wait a minute, no.
You use the largest X value. So I think we have to find what, over here on this explanatory variable, what is the highest X value, which is 5.93.
Oh, so we see what the highest one is. We don't choose 6.
Okay, yeah, I think that's right. Because there's a positive correlation, largest X value to find the predicted. Yeah, I think you're right, Jeannie.
Okay.
And what did you say it was?
5.93 is what I can see.
Yeah, I think that is going to be the biggest. I think 5.93.
Okay,
so then do we put that in for X, 5.93?
Well, they're not asking us for X. Yeah, that would be, I think, the way that we would do it. And then
so we would do 5.93. So our predicted Y would be 93.970.
But it's asking what is the maximum? Oh, yeah, maximum predicted. Okay. So they're not wanting the highest in the prediction interval.
Oh, wait. So,
right?
Okay, what is the maximum predicted value of Y? So the maximum predicted value would be 116.536.
Well, that's the prediction interval. I'm not sure. I think maybe you were right, and what they want is the
93.970.
Well, we can put it in there and see. And
so are we thinking 93.970?
Yeah.
That's what I think, yeah.
93.970. Okay. How many independent variables are present in simple linear regression?
Isn't it just 2?
Okay, Jennifer texted and said, the answer I got was 94.479, and I was wrong for that last one.
94.479?
Yeah, and she said she did it by hand.
Okay, so let me do it by hand really quick and see if that's what. So 18.690 plus 695 5.93.
She says question 13 is 1.
Yeah, so when I do it by hand, I get 93.971. So
okay,
let's see if that. Oh. Huh. Okay. How many explanatory?
Okay, so 13, we're going with 1.
I'm not sure I understand what that question's asking.
Oh, so you can have. So can you have multiple response variables? but only one explanatory variable?
How many explanatory or independent variables are present in simple linear regression? Maybe she wasn't saying A, maybe she was saying 1. You can only have one explanatory variable, but maybe you can have more than one. That makes sense to me.
Okay, so say that one more time. So we can only have one independent variable.
Okay. Jennifer says, look at question 14 too, and that will help you.
Oh, and how many in one? Okay,
Yeah.
one dependent. Okay.
So we can have more than one. Can we have more than 2 response variables? We can, can't we? No, simple?
No, not in simple.
In simple, we can only have one of each.
Right.
I think so. Because it's just talking about one variable there. So in our equation, it's just one variable for X and one variable for Y. Is kind of how I'm looking at it, but I don't know for sure.
Yeah, they never told us anything about more than one. And Jennifer says 14 is 1 also. So.
Okay. I feel good about that.
That makes sense to me.
That makes sense to me. Yeah.
Yeah.
Yeah, so if we had a multiple regression equation, we could have multiple independent variables.
Okay. That makes sense.
Yes.
Okay. Okay.
Okay. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes, meaning the company wants to predict the size of hat given the circumference. What is the response variable? So the company wants to predict the size of hat given the circumference.
The size of the hat would be the response then. Because
explanatory would be circumference, right?
Yeah.
Because that's what we have. But we're trying to predict the size of the hat given the circumference.
That's what I would say.
So response variable would be the size of the hat.
Mm-hmm.
You guys agree with that?
Yeah.
So it would be...
That's the one they're predicting. And
because it is the variable being predicted. So A for 15?
Right.
That's what I say.
Okay. Okay, I can go ahead and submit first and
Oh, that's it?
Okay. Jennifer says, I can't remember the choices, but I put A.
Okay.
Okay, I'll go ahead and submit it. I hope we got that one right with the, dang it.
We missed it?
We missed it. It's the confidence data one. The 93.9, number 12 is the one we missed.
Shoot.
So let me put in 116.536 and see.
A part of me feels like we need to put 6 in there because isn't that the maximum score?
Maybe.
Because it asks for what is the maximum predicted value of Y for, oh, but you know what? It says for these values of X.
Let me scan through there.
So maybe it is with...
Let me scan through there, make sure there's nothing larger than 593.
Okay.
You know what? I will just sort it. Oh, it's saying something about merge cells. Let me just do the date. It's not letting me because something about merged cells.
Okay, well, let me just submit this and see what.
Okay.
So what are you, Jeannie, going with?
With the confidence interval, the predicted interval for Y.
Okay. So with the 116,536?
Yeah.
There's a 5.97.
Oh, okay, because that's not it either. 116 is not it.
Let me look and see if there's
5.97.
Yeah, let me look. That's the highest I found was 5.97.
And that's 94.478. And Jen said that she put in 94.479.
Is that what she said?
So maybe it's 117.055.
That could be.
I don't know.
That might be why I got that different number. Yeah, because she found the higher. I don't know. That's weird.
The confidence? Well, do you want to try that, Jennifer, for 94.479?
Yeah, I could try that.
Sorry.
So you want, no, you're fine. You want me to try the 117 one?
It's worth a shot, I think.
Is that the one? Or the 94.478?
I think the 94.478.
Isn't that what Jennifer put in though and she got it wrong?
She put 479.
Oh.
Oh, wait.
Yeah, Jennifer.
Is that close enough though that it should give it to her if that was the case, just because it's a rounding thing, or?
No, she just said it was 94.478. So yeah, try the 117.055.
Huh. Because that would be the maximum. That would be the maximum value if it's the highest end of the confidence interval, right?
I don't know.
I don't know.
I'm not sure it's worth all of this, but I mean, other than to know how to do it, but. There's a positive relation.
Oh, Jennifer Jensen just texted and said her computer just crashed.
X.
So to me it has to be either 94.478 or 117.055.
Okay, sorry about that, guys. Okay, so which number did we decide to try?
The
I don't know. Either 94.478 or 117.055 would be my suggestions.
Okay, let's try the 94.478. And then if that doesn't work, I'll try the other one, okay?
okay,
Is that all right?
yeah.
Okay.
Yeah.
Whoops. That's not what I wanted. It's thinking.
Huh.
$16 out of 17.
Hmm.
So, and it was number 12. So it's not that one. So it must be that
117.
I don't know what else it would be.
I don't either. Yeah, I think it would have to be.
All right, I will try that one. And we'll see what happens. Oh, you know what? I've got to put in all my answers again, though. And I didn't write them down.
I wrote them down.
Let me get there. Sorry, guys.
You're all right. Yeah, I really think it's got to be the 117.055.
I don't know what else it would be.
Yeah.
Unless you have to
The
use
more-
a 6 instead of the 5.97. That's the only thing I can think of.
Yeah, but that doesn't make sense because it asks about this data. Okay.
Well, and it says hint, because there's a positive correlation, we can use the largest X value, which I'm assuming they're referring to the largest X value of our data set.
Yeah.
Yeah. Okay, what was the answer for 3?
3.20. Nope, that's okay because I'm doing this too. 4 is 1.5. 5 is 1. 6 is
Okay.
hot dog. 7 is A.
Okay.
8 is 139. 9 is 18.690.
Okay.
10 is 12.695. Or no, sorry, that's number 11 is 12.695. Sorry.
Okay, 12.695 is 11. And
Wait,
No, that's 10.
That's 10.
Sorry.
12.695 is 10?
Uh-huh.
Okay. And 11 is?
Now I don't have it. Hang on.
I have my quiz pulled up. 11
Okay.
is 69.469.
69.469.
Okay.
12 is, I would go with the one, what was it, 117.055.
117.55?
0.055. 117.055. 13 is 1 and 14 is 1. 15 is A.
Okay. And have any problems?
You cut out there, Jen. What did you say?
Oh, I was just mumbling about number 12.
I hope that's it.
Let me try that. And if not, I don't know what.
Oh, I don't either.
Okay, save all receives. Computer's kind of slow. Seventeen. Wrong one.
What?
There's. I must have went in wrong when I was putting them in.
Oh, I hope I didn't give you a wrong answer.
Uh-oh, that's all right. The worst I can get was what I got last.
That's true. You're
time.
still good at a 16.
So was 12 still wrong?
12 is still wrong.
Wow, I don't know, guys.
Okay.
And I got 3 wrong. 3.2 instead of 2.0 for some reason. Oh, I think you said question 3 is, and I think I just threw that 3 in there.
Oh,
Oh, shoot.
I told you it's 3.20.
I think
Sorry.
no, it is not your fault. It's my bad.
No, it was my fault because I did the same thing on mine. 0.20.
Okay. So I have no idea how we do 12. I don't remember anything like this in the practice stuff.
Well, so the maximum, so what is it? So maximum predicted value of y. I'm just going to try 6 in there. And okay, so 94.859. We'll give that a shot. What?
Maybe it would need to be 6. Says the confidence, the value of confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y of x? Maybe these values of x was referring to the scale of 1 to 6.
That's the only thing I can think of. So let's see.
Anything else?
9, 10, 11. Yep, that's it. 94.859. So the x needs to be 6.
Okay, so we put 6 in for
6.
X.
Uh-huh.
And it's 94.859.
Yeah.
And you checked it and it's right?
Yeah.
Awesome.
And
Okay.
I missed another one, so I must have done the same thing.
Shoot.
Oh, yeah, I put 0.20 instead of 2.0.
Shoot.
But yeah, so that one's the right
Well,
one.
right.
I guess if I were really concerned, I could email her. All of that work.
Well, that's good to know.
Yeah, that is.
Yeah. Okay.
All right.
So stupid.
Yeah.
All right. Well, okay. So have fun driving, Jen.
Yeah. Thanks for your help.
And
All right.
for the survey info, I don't know what we decided, but I did get one more vote for option 1 and one more vote for option 2.
So does that give us 10 for option 2?
I think it gives us 9.
Oh,
But do you think we can still enter that into the things that we do, or?
yeah, I think so. And just maybe make a note that we got 2 more responses.
Yeah.
Okay.
Okay.
We just really need somebody dysfunctional to answer our thing and tell us that
I
they like
know. I know.
All right.
Yeah, that would be helpful.
Okay. Well, I guess we'll see you Tuesday.
Okay.
Yep.
No, when were you somewhere